Here's a scary topic, vectors. I'm here just to show you that vectors aren't actually that scary. As long as you remember three things. 1, vectors are just directions. 2, be careful about going backwards. And 3, halfway just means half the vector. But we'll come back to each of these. First of all, what is a vector? Here they've said OA, which is the root between O and A on this hexagon, is A. Now often the vector will be in bold or underlined. I've done both just for effect. So OA is the vector A. So anything going in that direction for that same length we could also call A. For example, D to C. That's the same direction, parallel to O and A, so that would also be A. Or perhaps from the middle here to B, that would also be A. It's the same length and the same direction, so it's the same vector as A. A doesn't just mean this line here, it means any time you go that same distance in that same direction. They've also said AB is the vector B. ED is the same vector, so that would be B. Or the midpoint here to the top, that would be B. That's the first thing to remember. Vectors are just directions. It doesn't just mean that single line, it means any time you go in that direction. Second thing is being careful about going backwards. Now A to B is the vector B, but B to A would be minus B. So when you go the wrong way, as in when you go down through the arrow instead of following the arrow, you need to remember the minus sign. The arrow just indicates the positive, correct direction. You are allowed to go backwards, but you need to remember a minus. Same thing, if we're going to go from A to O, instead of from O to A, it wouldn't be A, it would be minus A. With that knowledge, we can now do any vector on this diagram. So for example, B to C. That seems complicated because we know what O to A is, which is this direction, or A to B, which is north, but B to C, that's a completely new direction. But we can get there using the directions that we know about already. For example, what's B to this center point? B to this center point is this direction, or opposite to A. So opposite to A, what does that mean again? Minus A. Just to recap what we're doing, we're trying to get from B to C, and we don't know what that direction is. We know what north is, we know what northeast is, but we don't know what B to C is. So we're going to get there using the directions we know about. We're going to go down here and then up. This direction is almost exactly the same as this one, except it's backwards. So instead of calling it A, we're going to call it minus A. What about from the center up to C? Well, that's just the vector B. We don't need to do minus B because it is just simply B. We're going in the right direction. We're following the arrow. If A to B is B, well then the center to C is B. It's the same length, same direction. So in total, we've got minus A plus B. And yes, that's exactly what you need to do. You can just put the vectors together. Minus A plus B. That will get you from B to C. Let's do another one. What about O to E? O to E seems like difficult. We might have to do some rerouting again. But actually, O to E, that's the exact same direction as B to C. So O to E is also going to be minus A plus B. Let's do a weird one. D to E. I'm just making these up. I could be here forever. D to E. Well, A to B is B. What do you reckon D to E is going to be? It's the same length, but it's going in the opposite direction, so it would be minus B. Minus B. What about a hard one? What about O to C? All the way down here to up here. O to C. Well, that would be a B to get here, and another B to get to C. So that would be 2B. OC equals 2B. Don't know why this says IB. DE, no, that was minus B. Let's call that minus B, not IB. Okay, Let's do e to c. E to c. Well, we can go any route we want. We could go up here and then across, or across and then up. Let's go across and then up. So e to the center, well, that's just a, isn't it? It's exactly parallel and in the same direction as a. So e to the center is a, and the center to c is b. So it's simply a plus b. The next little thing I want you to know about, this point number 3 that a lot of students get hesitant about, is when they bring in midpoints. So M is the midpoint of D to C. All that means is you're going half the distance, so you need to half the vector. What is D to C, the whole way from D to C? It's just A, isn't it? Same direction, same distance, so D to C is A. So D to M is going to be a half A. We call it 1 over 2 or just 0.5 A. What if we wanted to go all the way from, let's do a hard one, O to M. So we're going to go all the way from the bottom to that midpoint. This is going to be epic, like some sort of Hobbit quest. Okay, O to M. How about we go O to the center? So O to the center, well, that's up by 1, so that's just a B vector. This direction from the center to D, that's the one we found out about before. That's the same as B to C, or the same as O to E. And we found out before that was minus A plus B. So we've got to add in a minus A and a plus B. So we've got all the way from O to D so far. We went up, then across. Now from D to M, we know is a half A. So let's add in a half A. And if we sum up all of these different vectors that we did on our journey, we get the final answer for what O to M is. B plus B is 2B. Or is it not to be? Lame joke. And minus A plus a half A, well, what's minus 1 of something plus half of that thing? You're at minus a half of that something. So O to M is minus a half A plus 2B. And that's vectors, not so scary after all.